Alright, let's take a look. So let's check out our view of the moon from the Earth. You may not have noticed this, but we actually always see the same side of the moon. Only one side of the moon is actually pointing at the Earth. Now, the only way for this to happen is if the moon rotates in the same amount of time that it revolves or orbits around the Earth. So one rotation and one orbit actually take the same amount of time for the moon. When this happens, where we only have one side facing what it's orbiting, this is known as synchronous rotation, and we're actually going to mention it several times, so make sure you get the term synchronous rotation down. Okay, so with synchronous rotation, one face is pointing towards whatever it is orbiting, and that also means that one rotation is the same amount of time as one orbit or one revolution. So I really like this sequence of images. So this is a full cycle of phases, but notice that at every phase, we actually still only see the one side of the moon. Okay, so we really do only have one side facing towards us. Now, to hopefully help convince you that the moon does actually must rotate for this to happen, we're going to start with the counterexample. What would we see if the moon did not actually rotate as it orbited around the Earth? And so here we have the Earth at the center, and then the moon at new, first quarter, third quarter, and full, and then out here we've got the sun. So starting with the moon at new moon, we've highlighted two craters, red and blue. So at new moon, as we look towards the moon, all we see is the red crater. Then, over time, the moon orbits around the Earth, and notice it's gone through 1/4 of an orbit, but the moon itself has not rotated at all. The blue crater is still facing towards the sun. So as we look towards the moon, now that it is at third quarter, we can kind of see the red crater, we can kind of see the blue crater. We actually get both of them. We did not have that view before during new moon. Then the moon continues through 1/4 of its orbit as we look up at it. Now in this case, we are now at full moon, and at full moon, all we see is the side with the blue crater. The red crater is on the far side now. Then we go through another 1/4 of the cycle, and again we see a little bit of red and a little bit of blue, but notice it's now the opposite side of the moon as it was before. So what this means is if the moon did not rotate, then we would actually end up seeing all of the different sides because of its orbit around the Earth. So what's actually going on? Here we see what is really happening. So again, we start out with new moon. Again, we have red and blue craters highlighted. As we look up during new moon, we have the red crater pointing at us. Then the moon goes through 1/4 of its orbit, and notice it has now rotated by 1/4. Because it's orbited and rotated by 1/4 as we look up, we still only see that red crater. Then we go through another 1/4 of the rotation and another 1/4 of the orbit, and as we look up, again, we still only see that red crater. So again, this is synchronous rotation, and it means that we only ever see one side of the moon. Now, we've mentioned previously how we keep track of time based off of the sun. We also at least used to keep track of time based off of the moon. And so you've probably heard of a month. Now, that's not at all how we pronounce it today, but the term month actually comes because of the moon. Now, just like there were two different types of day, there was a solar day and a sidereal day, there are two different types of month. There is a sidereal month and a synodic month. Now, if you remember previously, we mentioned sidereal means according to the stars. So a sidereal month is a month according to the stars. A sidereal month is then the amount of time it takes for the moon to be in a constellation. Now remember, our new definition for constellation is a region of sky. So it's the time it takes for the moon to be in a region of sky until it cycles all the way around the sky and gets back into the same constellation, back into the same region of sky. Okay, so this is a sidereal month, and this takes about 27 1/3 days. The other type of month is the synodic month. A synodic month is a full cycle of phases. So from new moon to new moon or full moon to full moon is a synodic month. Okay, so synodic month is according to the phases. Now this takes about 29.5 days. Okay, so a sidereal month is actually a little bit shorter than a synodic month. Now, if you remember back, we mentioned that a solar day was slightly longer than a sidereal day. A sidereal day is 4 minutes shorter than a solar day. Okay, we actually have a similar thing happening here, where they're not in sync. And it turns out that it's actually for the same reason. So as the moon orbits around the Earth moves around the sun. So for the moon to get back into the same constellation, so let's say the constellation Scorpius is out in this direction. For the moon to get back in line with Scorpius, it only has to get back to the same place in its orbit. In other words, it only has to complete a full 360-degree circle. That is it. Then it's lined back up with the stars. But for it to line back up with the sun, so in this case we've got new moon, then as the Earth moves, the sun is going to drift position in our sky, so the moon has to travel farther to then line back up with the sun in our sky. So because of that, a synodic month is that 2 and a little bit days longer than a sidereal month, because we are orbiting around the sun, which means when we're comparing to the sun, things take a little bit longer.